Alright guys, welcome to the second week of graphing sine and cosine. Our objectives are going to be the exact same as last week. We're just going to touch on a few different concepts. So your first objective is graph sine and cosine functions, and our second one is to be able to identify all the features of our sine and cosine graphs. Okay, so I just wanted to go over the transformations for this week. So we have a couple of them. The two transformations that we are mostly focused on is going to be the B and the C. Okay, so last week we saw the A and the D. We saw what they did. So the B and the C are going to focus on the horizontal aspect of the transformations, whereas the A and the D focus more on the vertical transformations. So a couple things we need to realize with our B values, right? So this is going to be the most important one, is the B value. So the B value is going to control the period, right? So this guy is going to it's going to determine what the period is. So whatever number it is tells you the size of it, determines the period. So let's look at the parent function first, and we're going to see. So this is the original parent function right here. This is just y is equal to sine, right? This is just y equals sine of theta. In this case, your b value is going to be 1. Okay, so let's look down. Let's write down here at the bottom that when the b value is 1, right, the period is going to have a length of 2 pi. Okay, so when the period is 1, the length is 2 pi. The way I want you to think about the b value and the p value, the way this is going to make the most sense is if you think about the b value as being like the speed at which you travel around the unit circle, and the p is going to be the time it takes. Right. That's not necessarily what it means, but this is one interpretation of it that I think is going to help make the b value make a lot more sense. So now what I want to do is I want to look at a b value of, let's say, 2. So let's say we have a b value of like 2, right? Let's say the b is equal to 2. So this is speed, right? So let's say you are traveling twice as fast around the unit circle. How much time is it going to take you to go around the unit circle? Well, if you're going twice as fast, it should take you half the amount of time. So if we go twice the speed, then what's half of the period, right? So if this is the original period, and now we're going twice the speed, so it's going to take us half the amount of time to get there. So this is going to give us a distance of pi. So now let's go ahead and graph this out. So now we're going to go through the entire process of sine all in just pi, right? So you're going to note, well, let's see, let me do my best here to kind of squeeze it in. There we go. Much better. Okay. So that is going to be a b value of 2, right? That's only going to be a distance of pi. So now let's look at it. What if we had a b value of, let's say, 1/2? Right, what would happen if I have a b value equal to 1/2? Well, if you're going half of the speed, right, if we're going half the speed around the unit circle, how long will it take us to get there? Well, it's going to take us twice as long. So we're going to have to multiply this by 2. It's going to take us twice as long. So it's going to be a distance of 4 pi. So if that's 2 pi, let's say 4 pi is all the way out here, right? Let's say 3 pi is there and 4 pi is all the way out here. Right, this is 4 pi. Okay, so sine is now, this is now going to become twice as long. All right, and this is going to be the new period of this. So let's go through these 3 examples again and see what's happening here. So if we go to the original, right, we can see that in the original graph, right, the b value is 1 and the period is 2 pi. And then as the b value gets bigger, the period is now going to get shorter, right? So we can see, notice how the width of the graph is now getting changed, right? That's what the b value does. It changes the horizontal width of your graph. And then as we make our number smaller, this is now going to get twice as long. So now we're noticing the smaller the number is, the longer the period is going to be, right? The bigger the number is going to be, the smaller the period is, right? So hopefully that kind of helps you out. So the tricky thing about the b value is that the b value is going to have an inverse relationship with the period, right? So the b value has what we call an inverse relationship with the period. Right? So the way you want to think about an inverse relationship is think about it as the things go the opposite direction. Right? As one gets bigger, the other one gets smaller. Right? This is an inverse relationship. As one thing gets smaller, the other one gets bigger. So that's the idea there. How did we calculate the period though? If you notice the way I calculated, I took the original. Oh, you know what? Let me make this more like a formula, right? The period is going to be equal to whatever the original period is, so in this case 2 pi, and then we're going to divide it by whatever the b value is. And the way we're going to apply the b value when we graph is we're going to take the x value and we're going to multiply it by the b value. No, I'm sorry, multiply it by the reciprocal of the b value, right? Because of that inverse relationship. So definitely two things you need to have in mind there. Okay, now let's look at the c value. So we did the b value. Now the c value in this case, this is just going to move your graph left or right. So there's not really a lot I need to show you here because it's pretty straightforward. We've been doing this throughout the year, but the one thing you do need to know is that this is known as the phase shift. Okay, so we just call that the phase shift. And this is going to apply to the x value. So we take the x value and we're going to subtract. We're going to do the opposite of whatever the c value is. So if it's positive, we subtract. If it's negative, we're going to add it, right? So it's always the opposite. All right, let's go ahead and look at some examples. Okay, so for this first example, we're going to go ahead and graph y equals the sine of 2 theta. So let's go ahead, we're going to start off with our parent function here. So I already have some of the points listed there. So then at pi, we've got 0. At 3 pi over 2, we've got -1. And then at 2 pi, we've got 0. So now we get this shape, right? This is just everything we did last week. So nothing new here. Okay, but the first thing that's new here that we're going to notice is that we have a b value. So that is going to change the period of this graph. So what we're going to do first is we're going to create a new graph by multiplying all of the x values by the reciprocal of that guy, right? So remember the inverse relationship? So what happens here is we're going to multiply by the reciprocal. So times the reciprocal of 2 is 1/2. So I'm going to multiply everything by 1/2. All right, and then whatever our answer is, we're going to just rewrite that. So 0 times 1/2 is 0. So we're going to multiply straight across. So this will give me pi, and then on the bottom I get 4. If you don't have a Denominator, go ahead and add 1. We'll multiply these out. So we get pi over 2. Multiply the top here, I get 3 pi. And then multiply the denominator, I get 4. And then here on the top, we're just going to get 2 pi over 2, which is just going to round to pi. Okay, so there we go. Let's go ahead and graph our new function here, our sine of 2 theta. So we just need the piece of the table. So 0, 0, 0, pi over 4, which is halfway here, up 1, pi over 2, 0, 3 pi over 4, negative 1, and then pi 0. Right, so all these guys right in between are going to be pi over 4s, right? This is 1 pi over 4, and then this is 2 pi over 4, and then this is 3 pi over 4. So that's how we can kind of tell what goes on the x-axis. And then we're going to go ahead and connect our points here, and there we go. And that's our graph. Let's go ahead and identify all the features of this graph now. Okay, so I only want to identify the features of the graph in the blue there. So we're going to start with the domain, which we already know is going to be all real numbers, right? We know the range is just going to be from -1 all the way to 1. The amplitude is going to be the same for all the problems here, because we're not really dealing with the, remember this is the a value, but we're not really dealing with the a value, so it's always going to be 1. The period is going to change today though. So we're going to start with 2 pi, and remember we divide it by whatever the b value is. So we have 2 pi, and we're going to divide it by the b value, which is 2 in this case, right? My b value is going to be this guy right here, so that's your b. And we're going to go ahead and simplify our period here. So we're going to end up with the 2's cancel out and get just pi. And that makes sense, right? We can see our period here has a length of pi. It goes from 0 all the way to pi. Our x-intercepts, so we can see our x-intercepts are going to start. I like to just list the x-intercepts as we start. So I see there's 1 at 0. I see there's 1 at pi over 2. And then I see there's 1 at pi. And then you just want to find, okay, what's the distance between these 3 values, right? What's the distance from one to the other, right? From here to here, what's the distance? And from here to here. Well, it's a distance of pi over 2. So that's going to help us because we want to write an equation for this. So we're going to say, we're going to just pick one of these. I always like to pick 0, but you can pick pi over 2 or pi, it doesn't matter. I'm going to pick one of those, and then I'm just going to add and subtract. Well, actually, you don't have to subtract it because we'll see why right now. Plus that distance, right, pi over 2, and then times k, times the k value. So this is going to be our equation here. That's going to give you all the x-intercepts. Because they're starting at 0, every pi over 2 away, you'll continue to get all the values, right? Or if you go backwards, right, you'll get the negative ones, right? Negative pi over 2, negative pi, right? So the k value is just going to be, is just telling you which one you want, right? This is k equals 1, this is k equals 2, this is k equals negative 1, this is k equals negative 2, right? So your k value is really just made up of all the integers, right? From negative 1 all the way to infinity. I'm sorry, from negative infinity all the way to positive infinity, but just whole numbers. Okay, y-intercept, this one is just 0, 0. And then we have interval of increase or decrease. So we can see it's increasing from 0. Let's get black out again. We can see it's increasing from 0 to pi over 4. And then it's also increasing from 3 pi over 4 to pi. And then it's decreasing right in between those. So from pi over 4 to 3 pi over 4.